Hey everybody, Richie Rich here. Today, I'm back with another YouTube video. In this video, I'm gonna be doing something a little bit different right now. It's still with cars, but yeah, it's a bit wet because I put it on a table and is that a smoke? It's getting cold outside. Temperature's 0 degrees. On my phone it says 0 degrees. So I'm gonna do this quick video, and then I'm gonna go back inside because I don't want to be out here for so long. I don't want to get like sick or anything. So let's do it. So what I'm gonna be doing, So what I'll be doing is variable cam timing. So I have done the video on the A.A. and the Mustang. Now I've done a video on an Asian car and an American car. Now I will be doing a video on a European car, and I want you guys to have a guess of what European car it might be, and I will do that video for you guys. So it's like the continent cars that I'll do. So like American, Asian, and then it's all the way to European. So yeah, that will have to wait though. That will have to wait. And so yeah, maybe next week I might do it. I don't know, but whatever I have in mind, I might be able to do it if I have the time. But yeah, so let's do it. So I'm gonna be talking about variable cam timing. So let's do it. Variable cam timing, VCT for short, is an automobile variable valve timing technology developed by Ford. It allows for more optimum engine performance, reduced emissions, and increased fuel efficiency compared to engines with fixed camshafts. So yeah, increased fuel efficiency compared to engines with fixed camshafts. It uses electronically controlled hydraulic valves that direct high-pressure engine oil into the camshaft phaser cavity. These oil control solenoids are bolted into the cylinder heads towards the front of the engine near the camshaft phasers. The powertrain control module, PCM, transmits a signal to the solenoids to move a valve spool that regulates the flow of oil to the phaser cavity. The phaser cavity changes the valve timing by rotating the camshaft slightly from its initial orientation, which results in the camshaft timing being advanced. The PCM adjusts the camshaft timing depending on factors such as engine load and RPM. Next up is the history of it. For twin cam or DOHC engines, VCT was used on either the intake or exhaust camshaft. Engines that have VCT on both camshafts are now designed as TI VCT. The use of variable camshaft timing on the exhaust camshaft is for improved emissions, and vehicles with VCT on the exhaust camshaft that don't require exhaust gas recirculation, EGR for short, achieves the same result. VCT on the intake camshaft is used primarily for increasing engine power. So yeah, VCT on the intake camshaft is used primarily for increasing engine power and torque, as the PCM powertrain control module is able to optimize the opening of the intake valve to match the engine conditions. VCT is used in Ford's Triton 5.4-liter 3-valve V8 engine, the Australian Barra 182 and 240 inline 6s, and Ford's 4.6-liter 3-valve V8 engine used in the 2006, 2010 Ford Explorer and 2005-2010 Ford Mustang GT. The 2-liter Z-Tech inline 4 used in the 1998 to 2003 Ford Escort ZX2, Ford Contour, and the 1999 to 2002 Mercury Cougar used VCT on the exhaust camshaft. The 2002 to 2004 SVT Focus ST-178 in Europe also featured VCT, but on the intake camshaft on its modified version of the 2-liter Z-Tech engine. In addition, the 1.7-liter Z-Tech S engine found in the European Ford Puma was equipped with variable camshaft timing. The 6.2-liter V8 introduced in the 2010 SVT Raptor also used VCT. That motor has a single cam per bank, so it's dual equal variable cam timing. Alright, next up is TIVCT. Twin Independent Variable Cam Timing, TIVCT for short, is the name given by Ford to engines with the ability to advance the timing of both the intake and exhaust camshafts independently. Unlike the original versions of VCT, which only operated on a single camshaft, this allows for improved power and torque, partially at low engine RPM, as well as improved fuel economy and reduced emissions. Some Ford TIVCT engines use Borg-Warner's cam torque actuation (CTA), which utilizes the existing torsional energy in the valve train to rotate the camshaft. My fingers feel stiff when I do that. Anyways, instead of traditional oil pressure driven cam phasing, many new Ford engines feature TIVCT, including ones used in the 2011-2015 Mustang, 2011 Edge and Edge Sport, 2011 Lincoln MKX, 2011 Fiesta, 2011 Explorer, 2011 and 2016 Ford F-150, and the 2012 Ford Focus. The engines using the CTA system is the 5.0 Coyote, and the engines without using CTA system is the 3.7 Cyclone. Next up is variable valve timing. In internal combustion, there we go, third time's the charm. In internal combustion engines, variable valve timing (VVT) is the process of altering the timing of a valve lift event, and is often used to improve performance, fuel economy, or emissions, whatever you say, whatever it is. It's increasingly being used in combination with variable valve lift systems. There are many ways in which this can be achieved, ranging from mechanical devices to electro-hydraulic and camless systems. Increasingly strict emissions are causing many automotive manufacturers to use VVT systems. Two-stroke engines use a power valve system to get similar results to VVT. Next up is the background theory. The valves within an internal combustion engine are used to control the flow of the intake and exhaust gases into and out of the combustion chamber. The timing, duration, and lift of these valve events have a significant impact on engine performance. Without variable valve timing or variable valve lift, the valve timing is the same for all engine speeds and conditions. Therefore, compromises are necessary. An engine equipped with a variable valve timing actuation system is freed from this constraint, allowing performance to be improved over the engine operating range. Piston engines normally use valves which are driven by camshafts. The cams open the valves for a certain amount of time during each intake and exhaust cycle. The timing of the valve opening and closing relative to the position of the crankshaft is important. The camshaft is driven by the crankshaft through timing belts, gears, or chains. An engine requires large amounts of air when operating at high speeds. However, the intake valves may close before enough air has entered each combustion chamber, reducing performance. On the other hand, if the camshaft keeps the valves open for longer periods of time, as with a racing cam, problems start to occur at the lower engine speeds. Opening the intake valve while the exhaust valve is still open may cause unburnt fuel, which is fuel that is not burnt, to exit the engine, leading to lower engine performance and increased emissions. According to engineer David Vizard's book, Building Horsepower, as he called his book, when both the intake and the exhaust are open simultaneously, the much higher pressure exhaust pushes the intake charge back out from the cylinder, polluting the polluting I was just about to say air, polluting the intake manifold with exhaust in worst cases. Next up is continuous versus discrete. Early variable valve timing systems used discrete, which is stepped adjustment. For example, one timing would be used below 3,500 RPM and another used above 3,500 RPM. Most advanced continuous variable valve timing systems offer continuous infinite adjustment of the valve timing. Therefore, the timing can be optimized to suit all engine speeds and conditions. Next up is cam phasing versus variable duration. Sorry. Sorry about that. I'm a little bit unwell, I'll be honest with you. Alright. The simplest form of VVT is cam phasing, whereby the phase angle of the camshaft is rotated forwards or backwards relative to the crankshaft. Thus, the valves open and close earlier or later. However, the camshaft lift and duration cannot be altered solely with a cam phasing system. Achieving variable duration on a VVT system requires a complex system such as multiple cam profiles or oscillating cams. Alright, next one is typical effect of timing adjustments. This one is late intake valve closing, LIVC for short. The first variation of continuous variable valve timing involves holding the intake valve open slightly longer than a traditional engine. This results in the piston actually pushing air out of the cylinder and back into the intake manifold during the compression stroke. The air which is expelled fills the manifold with higher pressure, and on subsequent intake strokes, subsequent intake strokes, the air which is taken in is at a higher pressure. Late intake valve closing has been shown to reduce pumping losses by 40% during during partial load conditions, and to decrease nitric oxide, which is NOx, brackets, emissions by 24%. Peak engine torque showed only a 1% decline, and hydrocarbon emissions were unchanged. Early intake valve closing, EIVC for short. Another way to decrease the pumping losses associated with low engine speed, high vacuum conditions is by closing the intake valve earlier than normal. This involves closing the intake valve midway through the intake stroke. Airfill demands are so low at low load conditions, and the work required to fill the cylinder is relatively high, so early intake valve closing greatly reduces pumping losses. Studies have shown early intake valve closing reduces pumping losses by 40% and increases fuel economy by 7%. It also reduces nitric oxide emissions by 24% at partial load conditions. A possible downside to early intake valve closing is that it significantly lowers the temperature of the combustion chamber, which can increase hydrocarbon emissions. Early intake valve opening is the next one. Early intake valve opening, EIVO, is another variation that has significant potential to reduce emissions. In a traditional engine, a process called valve overlap is used to aid in controlling the cylinder temperature. By opening the intake valve early, some of the inert combusted exhaust gas will backflow out of the cylinder via the intake valve, where it cools momentarily in the intake manifold. This inert gas then fills the cylinder in the subsequent intake stroke, which aids in control the temperature of the cylinder and nitric sorry oxide emissions. All right. It also improves volumetric efficiency because there is less exhaust gas to be expelled on the exhaust stroke. I was gonna say intake in a minute. I was just about to. Sorry. Early late exhaust valve closing. Early and late exhaust valve early in the can't say it. Early and late exhaust valve closing timing can be manipulated to reduce emissions. There we go. Traditionally, the exhaust valve opens and exhaust gas is pushed out of the cylinder and into the and into the exhaust manifold by the piston as it travels upwards, which is basically going up. By manipulating the timing of the exhaust valve, engineers can control how much exhaust gas is left in the cylinder. By holding the exhaust valve open slightly longer, slightly longer, there we go. The cylinder is emptied more and ready to be filled with a bigger air-filled charge on the intake stroke. By closing the valve slightly early, more exhaust gas remains in the cylinder, which increases fuel efficiency. This allows for more efficient operation under all conditions. Next up is the challenges. The main factor preventing this technology from wide use in production automobiles is the ability to produce a cost-effective means of controlling the valve timing under the conditions internal to an engine. An engine operating at 3000 RPM will rotate the camshaft 25 times per second, so that valve timing events have to occur at precise times to offer performance benefits. Electromagnetic and pneumatic camless valve actuators offer the greatest control of precise valve timing, but in 2016 are not cost effective for production vehicles. Got the history. Now there's steam engines, so hell, why not? I'll just do it. The history of the search for a method of variable valve opening duration goes back to the ages of steam engines, when the valve opening duration was referred to as steam cutoff. The Stephenson valve gear, as used on early steam locomotives, supported variable cutoff, that is, changes to the time at which the admission of steam to the cylinders is cut off during the power stroke. Early approaches to variable cutoff coupled variations in admission cutoff with variations in exhaust cutoff. admission and exhaust cutoff were decoupled with the development of the corpless valve. These were widely used in constant speed variable load stationary engines, with admission cutoff and therefore torque mechanically controlled by a centrifugal governor and trip valves. As poppet valve sorry. There we go. As poppet valves came into use, a simplified valve gear using a camshaft came into use. With such engines, variable cutoff could be achieved with variable profile cams that were shifted along the camshaft by the governor. The Serpollet steam cars produced very hot, high-pressure steam requiring poppet valves, and these used a patented, I can't even say that word, sliding camshaft mechanism, which not only varied the inlet valve cutoff, but allowed the engine to be reversed. Next up is aircraft. An early experimental 200 horsepower Clerget V8 from the 1910s used a sliding camshaft to change the valve timing. Some versions of the Bristol Jupiter radical engine of the early 1920s incorporated variable valve timing gear, mainly to vary the inlet valve timing in connection with higher compression ratios. The Lycoming 7755 engine had a variable valve timing system consisting of two cams that could be selected by the pilot. One for takeoff, pursuit and escape, the other for economical cruising. Next up is automotive. The desirability the desirability of being able to vary the valve opening duration to match an engine's rotational speed first became apparent in the 1920s, when generally starting to rise. Until about this time, an engine's idle RPM and its operating RPM were very similar, meaning that there was little need for variable valve duration. The first use of variable valve timing was on the 1903 Cadillac runabout created by Allison Partridge, Brush, patent 767,794, inlet valve gear for internal combustion engines. Filed August 3rd, 1903, and granted August 16th, 1904, so it was a year later and 13 days. In 1958, Porsche made application for a German patent, also applied for and published as British patent GB861369 in 1959. So the end of the 50s, almost the start of the 60s. The Porsche patent used an oscillating cam to increase the valve lift and duration. The desmodromic cam driven via a push-pull rod from an eccentric shaft or swash plate. Swash plate, there we go. I was just about to say electric, but it's eccentric. Eccentric shaft or swash plate. It's unknown. Sorry. It's unknown if any working prototype was ever made. Alright. Pretty much there's like some European and Asian cars that use this kind of system. Fiat was the first auto manufacturer to patent a functional automotive variable valve timing system which included variable lift. I was gonna say increased, but included variable lift. Developed by Giovanni Torazza. I can say that. In the late 60s, the system used hydraulic pressure to vary the fulcrum of the cam followers. The hydraulic pressure changed according to engine speed and intake pressure. The typical opening variation was 37%. Alfa Romeo was the first manufacturer to use a variable valve timing system in production cars. The fuel-injected models of the 80s Alfa Romeo Spider 2000 had a mechanical VVT system. The system was engineered by ING Inc. What I can't even say. I don't even know how to say that. Gianpaolo Garcia in the 70s. All Alfa Romeo Spider models from 1983 onward used electronic VVT. In 1989, end of the 80s, Honda released the VTEC system, while the earlier Nissan NVCS alters the phasing of the camshaft. VTEC switches to a separate cam profile at high engine speeds to improve peak power. The first VTEC engine Honda produced was the B16A, which was installed. Sorry, I have a message. One of my friends that's just a friend of mine texting me. The first VTEC engine Honda produced was the B16A, which was installed in the Integra, CRX, and Civic Compact, or hatchback, available in Japan and Europe. In 1992, the early 90s, early 90s, Porsche first introduced VarioCam, which was the first system to provide continuous adjustment. All previous systems used discrete adjustment. The system was released in the Porsche 968 and operated on the intake valves only. Next up is motorcycles, which I really like motorcycles. Uh, if you guys want me to do like videos on like motorcycle infos, comment down below of what motorcycle you want me to do. If not, and you want me to stick on cars, I'll be glad to still stick on cars. Anything to do with like like cars, like anyway, like automotive like stuff. like like cars, bikes, anything. Alright, motorcycles. Variable valve timing has been applied to motorcycle engines but was considered a non-useful technological showpiece as late as 2004 due to the system's weight penalty. Since then, motorcycles including VVT have included the 2007 Kawasaki 1400 GTR with also the Concourse 14, the Ducati Multistrada 1200 from 2015. So yeah, 2007 was the Kawasaki 1400 GTR with the Concourse 14. From 2015, the Ducati Multistrada 1200. From 2017, the Yamaha YZF-R15 version 3.0. The Suzuki GSX-R1000R L7, which was also from 2017 for both of them. And from 2019, the BMW R1250 GS. Automotive nomenclature. I can't even say that word. I don't even know how it's pronounced. It's spelled Nomenclature. Nomenclature, I think? I don't know. Anyway, manufacturers use many different names to describe their implementation of the various types of variable valve timing systems. These names include... So, these are for different cars, basically. So, we got some American, some European, and some Asian as well. Alright, so for Subaru, they use AVCS and AVLS, Proton, CBS. For Nissan and Infiniti, CVVTCS, DCVCP, dual continuous variable cam phasing, that's for General Motors. DVT, desmodromic variable timing for Ducati. FSI, TFSI, TSI, and SI for Volkswagen Group. So this is a friend texting me still. For Mitsubishi, it's MIVEC. VCT for Ford. Nissan, it's N-VCT. Mazda, S-VT. Ford, TI-VCT. Then we got Vanos, which is variable Nockenwellen Steuerung. I don't know how to say that. That's a German word. It's spelled Steuerung. I don't know how to say that, but camshaft timing without and with added Valvetronic for BMW. Variatore di fase Alfa Romeo, VCT is for Alfa Romeo. Varocam for Porsche. VTEC and I-VTEC for Honda and Acura. VTI, BMW Group. VVL for Nissan. Valve Lift for Audi. And VVEL for Nissan and Infiniti. Oh god, we got a bit more. VVT for Chrysler, General Motors, Suzuki and Maruti Suzuki, Isuzu, Volkswagen Group, and Toyota. VVT-I, VVTL-I for Toyota and Lexus. VTVT for Hyundai as well. Next up is the methods for implementing variable valve control, VVC. Number one is cam switching. This method uses two cam profiles with an actuator to swap between the profiles, usually at a specific engine speed. Cam switching can also provide variable valve lift and variable duration. However, the adjustment is discrete rather than continuous. The first production use of this system was Honda's VTEC system. VTEC charges hydraulic pressure to actuate a pin that locks the high lift, high duration rocker arm to an adjacent low lift, low duration rocker arms. Next up is cam phasing. Many production VVT systems are the cam phasing type, using a device known as a variator. This allows continuous adjustment of the cam timing, although many early systems only use discrete adjustment. However, the duration and lift cannot be adjusted. Next up is oscillating cam. These designs use an oscillating or rocking motion in a part cam lobe, which acts on a follower. This follower opens and closes the valve. Some oscillating cam systems use a conventional cam lobe, while others use an eccentric cam lobe and a connecting rod. The principle is similar to steam engines, where the amount of steam entering the cylinder was regulated by the steam cutoff point. The advantage of this design is that adjustment of lift and duration is continuous. However, in these systems, lift is proportional to duration, so lift and duration cannot be separately adjusted. The BMW Valvetronic, Nissan VVEL, and Toyota Valve Matrix oscillating cam systems act on the intake valves only. Next up is eccentric cam drive. Eccentric cam drive systems operates through an eccentric disc mechanism which slows and speeds up the angular speed of the cam lobe during its rotation. Arranging the lobe to slow during its open period is equivalent to lengthening its duration. The advantage of this system is that duration can be varied independent of lift. However, this system doesn't vary lift. The drawback is two eccentric drives and controllers are needed for each cylinder, one for the intake valves and one for the exhaust valves, which increases complexity and cost. Next up is three-dimensional cam lobe. This system consists of a cam lobe that varies along its length, similar to a cone shape. One end of the cam lobe has a short duration, reduced lift profile, and the other end has a longer duration, greater lift profile. In between, the lobe provides a smooth transition between these two profiles. By shifting area of the cam lobe, which is in contact with the follower, the lift and duration can be continuously altered. This is achieved by moving the camshaft I can't say that word. AXIALLY. Axially, I think. I don't know. Sliding it across the engine. So a stationary follower is exposed to a varying lobe profile to produce different amounts of lift and duration. The downside to this arrangement is that the cam and follower must be carefully designed to minimize contact stress due to the varying profile. Ferrari is commonly associated with this system. However, it's unknown whether any production models to date have used the system. Two shaft combined cam lobe profile. Next one. God. The system is not known to be used in any production vehicles. It consists of two closely spaced parallel camshafts with a pivoting follower that spans both camshafts and is acted on by two lobes simultaneously. Each camshaft has a phasing mechanism which allows its angular position relative to the engine's crankshaft to be adjusted. One lobe controls the opening of a valve and the other controls the closing of the same valve. Therefore, variable duration is achieved through the spacing of these two events. Next The drawbacks to this design include, which is just problems. At long duration settings, one lobe may be starting to reduce its lift as the other is still increasing. This has the effect of lessening the overall lift and possibly causing dynamic problems. One company claims to have solved the uneven rate of opening of the valve problem to some extent, thus allowing long duration at full lift. Size of the system due to the parallel shafts, the larger followers, etc. Next up is coaxial. I don't know how to say that. It's spelled Coaxial. Two-shaft combined cam lobe profile. This system isn't known to be used in any production engines. The operating principle is that the one follower spans the pair of closely spaced lobes. Up to the angular limit of the nose radius, the follower sees the combined surface of the two lobes as a continuous smooth surface. When the lobes are exactly aligned, the duration is at a minimum and equal to that of each lobe alone, and when at the extreme extent of their misalignment, the duration is at a maximum. The basic limitation of the scheme is that only a duration variation equal to that of the lobe nose true radius in camshaft degrees or double this valve in crankshaft degrees is possible. In practice, this type of variable cam has a maximum range of duration variation of about 40 crankshaft degrees. This is the principle behind what seems to be the very first variable cam suggestion appearing in the USPTO patent files in 1925. The Clemson camshaft is of this type. Next up is helical camshaft, also known as combined two-shaft coaxial combined profile with helical movement. This system is not known to be used in any production engines. It has a similar principle to the previous type and can use the same base duration lobe profile. However, instead of rotation in a single plane, the adjustment is both axial and rotational, giving a helical or 3D aspect to its movement. This movement overcomes the restricted duration range in the previous type. The duration range is theoretically unlimited, but typically would be of the order of 100 crankshaft degrees, which is sufficient to cover most situations. The camera is reportedly difficult and expensive to produce, requiring very accurate helical machining and carefully assembling. Next up is camless engines. So it's like engines without camshafts, basically. Engine designs which don't rely on any camshaft to operate the valves have greater flexibility in achieving variable valve timing and variable valve lift. The only production car that uses the camless design so far is the Koenigsegg Gemera. Next up is the hydraulic system. This system utilizes the engine lube oil to control the closure of the inlet valve. The intake valve opening mechanism incorporates a valve tappet and a piston inside a chamber. There is a solenoid valve controlled by the engine control system, which gets energized and supplies oil through a non-return valve during the time of cam lift, and the oil gets filled in the chamber, and the return channel to the sump is blocked by the valve tappet. During the downward movement of the cam at a particular instance, the return passage opens and the oil pressure gets released to the engine sump. And that is it, guys. For my next video, I will be doing an information on a European sports car. So comment down below what European sports car you think I might be doing a video about on. And so yeah, I might do some more I got more cars coming up like very soon. I got more cars planned. I will be doing like some sports cars, muscle cars, luxuries, supercars, hypercars, exotics. You name which one you want me to do, I'll do it for you guys. And yeah, so depend on how long it will take, how long the information will be, pretty much. I think I might be able to do it. I don't know. So that'll be it, guys. If you guys like this video, you find this interesting, subscribe, like the video, comment down below. Like I said, comment down below of what you guys want me to do for like cars. I still got more cars I want to do, but I want you guys to like tell me like what you guys want me to do for cars. If you wish, I don't mind. But yeah, so I'll be doing my next car for next Wednesday. I've got the information almost done, pretty much. I've got like not that long left, like not much, man. I'm like halfway done on the info. Just got the other half left to do. So yeah, so I'll be doing that next Wednesday. So I will see you guys next Wednesday. Take care, and also very soon next week is actually my birthday, actually, so I'll be turning 17 next week. So wish me a happy birthday next week, because on that day I might be doing that video. I don't know, but I will find out eventually. So yeah, and then so yeah, I will be doing like, so at some point I will be taking a break from doing YouTube, because like very soon, like in a few weeks, is gonna be Christmas. So I'm gonna be taking a break from doing YouTube on Christmas, and like, so yeah, and I might be doing like more after Christmas. I don't know, but whenever I have planned, I might be able to do it. So yeah, that'll be it, guys. Like I said, like the video, subscribe, comment down below what you think about this. Is it informative? Is it interesting, helpful for you guys? Anything you would really want to comment down below on with this. So yeah, that'll be it, guys. So I'll be doing this next video next Wednesday. So until then, have a very happy day, and I wish you guys a very happy Merry Christmas. Wish me a happy birthday next week. So I'll be turning 17. I'm gonna be I'm gonna be a young teenager. So yeah, yeah, I'm still young though, but staying at a young age is like the best. All right, I gotta go now. I'll see you guys next Wednesday. No, sorry, next Wednesday. There we go. Sorry. Wish me happy birthday, and I wish you guys a very happy Christmas to you guys. So stay safe, always respect one another, and like you will get like amazing gifts. I guarantee you will. So be kind to one another, help one another, and yeah. So that will give you guys like good luck and everything else. So yeah, I will see you guys very soon. So have a Merry Christmas. Take care. Stay safe. I'll see you guys soon. Good luck.